Okay, another piece of this human environment system modeling or representing the human environment system is something we mentioned before, agent-based modeling. We talked about the stock and flow modeling where you have, let's say, a river coming in, there is a dam, and then there is an outlet to let people use the water. So what the dam is holding is the stock, and then flow is the river, incoming flow and outgoing flow. So you have flux and reservoir is what typically you would call it in chemical engineering or climate science and so on. So agent-based modeling is something different. Instead of constructing human environment systems with stock and flow modeling to grasp the complexity and dynamic change, it is also possible to model many systems from the bottom up. Agent-based modeling is a particular powerful way of doing so, allowing us to seek understanding and explanation by modeling the parts of the world we are interested in as agents and their interactions. These models show how simple and predictable local interactions can generate familiar but enigmatic global patterns. So we talked about complexity, and we'll talk a bit more about it. Complexity is where you have emergent solutions like the one we looked at in the previous chapter, where you have a big crowd dancing very nicely in a concert, and suddenly something happens, and then you have stampede potential or stampedes happening. So the agents are all the individuals, and their interactions are dancing together, and then the interaction is also when somebody shouts something and there is a panic and everybody starts running. So here we are, a visualization of Schelling's agent-based segregation model using NetLogo. The model starts with around 50% similar agents and different attitudes concerning the the acceptable proportion of similar neighboring agent, i.e. wanting 25%, 33%, 50% or 60% of their neighbor to be similar. So when you have a random distribution of one type of group with intermixed different type of agents, in this sense, this is with 25%, the patterns begins to emerge when you allow 33% of the neighbors that are not just like us. You raise it to 50%, and then you have 60%. The idea is that now you have created neighborhoods that are very homogeneous. So you think often there is segregation, and that active segregation is forcing people of one community, like the Italians, Koreans, Irish, Indians, whatever, to live together in one neighborhood, which may be poorer than others, or maybe richer than the local population, and so on. But the idea of Schelling's work, which won him the Nobel Prize, is that just self-preference can lead to self-selection and self-aggregation or segregation, where somebody, let's say you are moving to a new place, like I'm going to the US. I want to live in some place, then I try to find some Indian that knows which neighborhood is good according to their experience, then we just follow the advice and end up in the same neighborhood, and 10 other Indians follow the same thing, same advice, and then before you know it, you have the entire community of Indians living close by in one cluster. Then the schools begin to be dominated by Indians and local governments, so you end up having neighborhoods, which can be good if you want to eat good Indian food. You want to go to Little India or Little Italy for Italian food, and so on and so forth. So it's not always bad, but this just shows you how agent-based aggregation modeling actually works. Okay, so conclusion from the second edition, which has some overlaps with what we discussed from the first edition, but it doesn't matter. Many issues of risk, resilience and sustainability are complex and challenging to explain, understand and improve, especially as they require the integrated knowledge and effort of various actors from across functional sectors, administrative levels and geographical borders. So unfortunately, efforts to manage risk and resilience for sustainable development have tended in the past to reduce problems into parts that fit functional sectors and organizational mandates, which is a significant weakness as it continuously clouds the bigger picture. So here you are looking at symptoms and not the fundamental problem. Twig may be right when stating that multi-sectoral approaches are ideal in theory, but their complexity causes problems. However, we have no choice but to try to grasp such complexity, as the alternative has proven insufficient for decades. Managing risk and resilience for sustainable development is thus not about dividing issues into parts that fit the agenda or mandate of specific actors, but rather about grasping the dynamics and nonlinear interdependencies in complex systems. Right? That's the idea of the systemic archetypes, with limits to growth, limits and underinvestment, tragedy of the commons, and so on and so forth. To grasp this complexity, we need to construct human environment systems to represent the parts of the world in which we are interested. Human environment systems include structural and functional models, which include different elements and dependencies. We discussed this already in a first edition, but still it's worth repeating. These models can be either qualitative or quantitative. It may be challenging to mathematically model all dependencies between elements that appear on the surface to be involved in what the human environment system does. It is thus important to note that it is still possible to determine the most important structural aspect that lies behind the system's viability and performance. It means that qualitative methods can also elicit information on the human environment system's structural and functional aspects, which is central to explaining, understanding, and improving issues of risk, resilience, and sustainability. This is where indigenous knowledge comes in terms of qualitative information or qualitative methods. Okay, although it is impossible to know any system completely, the goal must be as rich and comprehensive a picture as possible. You can see that all these references, 2005, 2003, and so on, are in fact from the previous version. So some of the references are newer, beyond 2015, and those are added in the second edition. So it's not only formal expertise that is vital when constructing human environment systems to manage risk and resilience for sustainable development. The educated common sense of the other actors is also important and provides a degree of moral force and political influence to the results, as we had said before. Vickers takes this argument further when claiming that over many decades, things which used to be regarded as acts of God, war, famine, pestilence, and as part of the nature of things, such as crime, destitution, ignorance, now have become regarded as controllable and are hence assumed to be somebody's responsibility. So there are risks identified, and we saw how the concept of risk has evolved in the last few centuries. They can all be fixed. It is just a matter of know-how. It is true and welcome that the degree of our control is slowly extending, but the assumptions based on this extension are false and dangerous. Not everything can be fixed, and fixing is never just know-how. So these are called wicked problems, as we discussed already. There is always decision made at the cost of not fixing something else. Until both governors and governed have a common and realistic view of what can be controlled and how far and at what cost, the relations between them are bound to be disturbed, and these disturbances may be as dangerous to the system as any. So crime, for example, is a good or even destitution is a good example of how society as a whole can decide to have more and more police force, more and more arrests, more and more entries into people's properties without warrant, and so on and so forth. But as is known by now, those don't ever solve the crime problem. They may suppress them, but then it leads to other problems on education, quality of life, and so on. Hence, it is not only for effectiveness that managing risk and resilience for sustainable development demands wide participation of actors, but also for preempting public discontent by distributing responsibility and facilitating realistic expectations. Public discontent that seems to be increasing in the wake of recent examples of calamity. So this goes back to 2008, but that was probably the calamity of financial crisis, but you can look it up. Finally, this chapter introduces a toolbox for approaching the world as human environment systems, ranging from Venn diagramming to advanced spatial mapping and analysis for constructing structural models, and between causal loop modeling and micro worlds for constructing functional models. However, it's vital to realize that the more advanced tools are not necessarily better than the more elementary ones. They are simply different tools for different purposes, just like a hammer and a LiDAR. The hammer is good for hitting a nail, but a LiDAR is required for mapping and so on. Use the right tool for what you intend and can do with available time and resources. Use the right tool for what you intend and can do with available time and resources. Okay, so that's the addition to this second part on approaching the world. So we have a few more sections to add here as new chapters have been introduced in the second edition, which we'll come back and do, I think, in terms of grasping complexity and governing and governmentalization. These are in the new book part of the approaching the world as well. Okay.